Today's question is to use Cauchy's integral formula to calculate this function integral z squared over z squared plus 9 dz in z plus 3i modulus equals 1. So this function is same as the one we have already introduced, but in a different domain. So again, Cauchy's integral formula, we need to find the appropriate function f, which is analytic everywhere inside and on a simple closed contour C. We also need to find the appropriate point z0, which is interior to the C. So we can use this equation to calculate the integral function. Okay, so back to our question. The domain modulus z plus 3i equals 1. We know it is a circle with the center at 0 minus 3i and a radius of 1. So the next, we need to change the given function into some form with z minus z0 in the denominator part. We already know that we can change the denominator part in our question, z squared plus 9 into z plus 3i times z minus 3i. And let's do one more step, but this time I'm gonna use z squared over z minus 3i as the new nominator part, and use z plus 3i as the new denominator part. And here's the reason. So now we can say the f function fz is the new nominator part, z squared over z minus 3i. And this is analytic everywhere inside this closed circle. And by the way, the only point that is not analytic is when z at the point 0, 3i. But this point is outside of the circle, so we don't need to worry about that. Alright, and we're going to use the point z0 at 0 minus 3i. You may have already noticed that this is the center of the circle, so it is, of course, within the range. So now we have found the correct function f. We also find the correct point z0. The next step is to substitute. So we have integral z squared over z squared plus 9 dz equals 2 pi I times fz0. And z0 is minus 3i. We substitute minus 3i into z in the fz function, which is 2 pi I times 3i squared over minus 3i equals 2 pi I times minus 9 over minus 6i. So the final result is 3 pi.